Hello, my thoughtful teenagers, and welcome to another episode of Grade 10 Maths with me, Miss Lambert. We're still on the topic of algebra, but now we're going to take it a notch up by looking at variation. Yes, so we're going to look at variation. So first, you might want to know what is variation and how does this apply to algebra. Let's take a look at the definition for the term variation. Here it says that variation speaks to the change that occurs when variables increase. In other words, variation is the change that occurs in y when there is a change in x. Variation can be either directly or indirectly. Now all of that, what exactly are they saying? Let's continue to take a look closer at what variation really is. So now we're going to look at direct variation. What is direct variation? It says when y varies directly to x, when x increase, y also increase by a common multiplier. Now the common multiplier is a constant value. Here you can see the denotation of variation. The symbol in the middle looks like if you make a continuous x or incorrect mark if you are marking something wrong. So we say that y varies to x, or y varies directly to x. Now let's take a look at an example where direct variation occurs. It says here that if y is directly proportional to x, when y is equal to 10, x is equal to 2.5. You must determine the value of a, the constant value a. Remember I mentioned that there is a constant multiplier that is always present when we're dealing with variation. So yes, we have to determine what is that constant value. Then we need to determine the value of x when y equals 20 and the value of y when x equal 1.25. For the first example, which says if y is directly proportional to x and y is equal to 10, now we need to write these information down as we go. So we know that y is equal to 10. And they say that when x is equal to 2.5. So now we have a value for x. X is equal to 2.5. They want us to first determine the value of a. And we said that a is a constant multiplier. So for direct variation, we represent it to say that y varies directly to x. And they want us to calculate the value of the common multiplier. So because we're dealing with variation, there is a standard representation for these things. So we're going to have y is equal to a multiplied by x. Because remember, we have a value for y, we also have a value for x, but we do not know the value of a. Now we're going to substitute each value where the variable is. So for y, we know that y is 10, and that is equal to, we do not know the value of a, but we know the value of x, which is 2.5. Now this should take you back to the aspect of changing the subject of the formula. Because remember, we're trying to find a value for a, but we have a is being multiplied by 2.5. So we want a by itself, we need to perform the inverse operation. So we divide by 2.5, and with equation it must be balanced. So what is done on one side must be done on the other. So when we work this out, a and a will equate to 1. And remember, it does not cancel out, it equates to 1. And when we divide 10 by 2.5, we are going to get 4. So we can say that 4 is equal to a. And that is the value of a. Now that we know the value of a, we can continue to solve our other equations. So now that we know the value of a, we can go on to solve the second part. It says determine the value of x. We do not know the value of x when y is equal to 20. But we know the value of a. We just solved and we found that the value of a is 4. So we know that y varies directly to x, and we rewrite this to say that y is equal to a multiplied by x. Now we can go ahead and substitute where we have values. So we have y is equal to 20, which is what we have here. A is 4, and we do not know the value of x. Once again, we are changing the subject of the formula, so we divide by 4 because x is multiplying to 4, and we divide by 4. This will equal 1, and when we simplify 20 divided by 4, we're going to get 5. So in this case, when y is 20, x is equal to 5. And the last one asks us to determine the value of y when x is equal to 1.5. So we do not have a value for y. We know that x is equal to 1.25 and a is equal to 4. So y varies directly to x. Y is equal to ax. We do not know the value of y. It is equal to a, which is 4, multiplied by x, which is 1.25. So when we simplify y is equal to 4 multiplied by 1.5, we're going to see y is now equal to 5. So when x is equal to 1.5, y is equal to 5. And there you would have completed all 3 parts of your variation problem. So since we already looked at direct variation, let's take a look at what indirect variation really is. Now it says when y varies indirectly or inversely at x, when x increase, y also increase by a common multiplier. However, we must remember that the inverse of x is equal to 1 over x. So if y varies directly to the inverse of x, this is what your representation should look like. So y varies directly to the inverse of x, which is 1 over x. Now let's put some numbers in the place where those variables are to make a little bit more sense of this aspect of variation. Here we have another example. If y is inversely proportional to x and y is equal to 3 when x is equal to 6, they want us to determine a, the constant value a, b, x when y is 6, and c, y when x is 1.5. Example 2 states that if y is inversely proportional to x and y is equal to 3, now let's write these values down as we get them. Y is equal to 3 when x is equal to 6, so we have x is equal to 6. We need to determine the constant a. Now remember, when we talk about being inversely proportional or being varied inversely, we are talking about y being varied to 1 over x. Alright, so now that we have that, we can rewrite this using the standard equation, which says y is equal to a bracket 1 over x. Now this can be simplified to y is equal to a over x. Now we can go ahead to solve for a. So we rewrite the equation substituting. So we have 3 is equal to a over x. Now we want a to be written by itself, so we need to transpose this to make a the subject of the formula. So a is being divided by 6, so in order to get rid of it, we multiply by 6. This will equate to 1, and we multiply this side also by 6. So now we're going to have 6 multiplied by 3 is equal to a. When we work this out, we're going to see that 18 is equal to a. So now we have a value for a, and that value is 18. We can go right ahead and solve the other 2 parts of this variation problem. Now the second part says we must determine the value of x. We don't know the value of x when y is equal to 6. But we know the value of A is 18. So let's work. We write the general formula, which is y varies indirectly to x. This is equal to y a over x. Y in this case is 6, is equal to a, which is 18, and that is being divided by x. So we would like to have x equal to everything else, and x in this case is the divisor. So we need to multiply both sides by x. So we multiply by x and we multiply by x. When we do that, this x and that x will equate to 0. Now we are going to have 6x is equal to 18. I really hope you are following. So from this point, we want x by itself. 6 is multiplying to x, so we divide both sides by 6. This will equate to 1. So we have x is now equal to 3. And now we know that when y is 6, x is equal to 3. Now we can go ahead and solve the last part of our problem. We need to determine the value of y. We don't know that value when x is equal to 1.5. Now we know the value of a is 18. So we can work. Y varies indirectly at x. So y is equal to a over x. We do not know the value of y, but that is equal to a, which is 18, being divided by 1.5. So y is equal to 12. So when y is 12, x is 1.5. And there you have it, the working for inverse or indirect variation. So my thoughtful teenagers, let's recap what was done for this lesson. We looked at variation, and it says that variation is the change that occurs for y when there is a change in x. Additionally, we know that variation can be one of two things. It can either be directly or indirectly. We can also say indirect is the inverse variation. Here we can see a representation of y when it's varied directly to x, and then y when it varies indirectly to x. A common multiplier must be evident. That is one of the most important factors when you're dealing with variation. So in order for you to have some more practice, I would like for you to reference Mathematics, a Complete Course with CXC Question Volume 1, Exercise 7K, which can be found on page 319, and you are going to work questions 1 to 9. Now that will give you a great deal of practice on the topic of variation. So there you have it, my thoughtful teenagers, our lesson for today on variation. I really do hope you were able to clearly understand all the concepts that were outlined, and you are going to practice so that you can be excellent in solving questions that involve variation. I am Miss Lambert, thanking you for being here with me on this episode of Grade 10 Maths, and please ensure you do your homework, and I will see you next time. Bye bye.